Hello everyone. In this video, we will deal with the three problems of finding the total number of functions which are 1, 1 or onto. See, simply finding the total number of function is very easy. That is, you can use the formula. That is the number of elements in the codomain set power number of elements in the domain set. That is the formula to find out the total number of functions from set A to set B, where set A is a domain set and B is a codomain set. But how to find out the total number of bijective functions with certain condition, total number of 1 function or total number of onto function with certain conditions which is given in the question. So such type of questions are normally popular in the mains and advanced examination. So see, I have taken these three examples. These are the very basic examples to understand the how to find out the total number of 1 function or onto function with certain given conditions. See, first one is if A is the set containing these six elements 1, 2, 3, 4, 5 and 6, and B is the set containing 1, 2, 3 up to the 9 elements. Okay, here 6 elements, here 9 elements. Then number of strictly increasing. So this is strictly increasing. What do you mean by the strictly increasing function? First you should understand that strictly increasing function means function is always 1 function, means we are increasing the input, the output will go also increase. So for each and every distinct input we are having the distinct output, therefore the function is strictly increasing function. For example, y is equal to x function, y is equal to x straight line, you can see that it is a strictly increasing function. When we increase the input, output will also get increased. Okay, fine, that is the strictly increasing function from set A to B. But the condition is that fi should not be equal to y. So this is super important to solve such type of problems with certain condition. Fi is not equal to I for all I belongs to A. So there are two conditions. The function should be strictly increasing and also Fi should not be equal to I. That is important. Now coming to the question number second. See, here the number of bijective function. Now, what do you mean by bijective function? Bijective function means 1, 1 and onto. So to solve these questions, now students get confused whether we have to find out the 1, function or we have to find out the onto function, because they are asking about the bijective function. So the language of the questions, particularly this variety, finding the number of functions with certain condition, 1, function or onto function or bijective function, that is very very important. So they are asking the number of bijective function from set which containing 1, 3, 5, 7, 99 to the set containing 2, 4, 6, 8, 100, such that, then condition, such that f of 3 is greater than equal to f of 9 is greater than equal to f of 15, and like that it is going on. So this shows that this function is strictly decreasing. Here strictly decreasing function, strictly decreasing, because when you are increasing the input, output is going decrease. Okay, increasing input, okay, f3 3 input, then f of 9, but the output of f of 9 is less than the output of this f of 3, and same thing going on throughout. So therefore this is strictly decreasing function. So first question is of strictly increasing function means 1, function. Second question is strictly decreasing, but here they are asking bijective function. So strictly decreasing means again a 1, function. But what about the onto? That is important. So therefore there is a hint whether we have to find out 1, function or onto function. And one more important aspect in this question is that here it's strictly increasing, here is strictly decreasing. So f of 3 is greater than f of 9 only. This must be the condition for strictly decreasing function. Why they are saying f of 3 is greater than equal to f of 9. So f of 3 cannot be greater than or equal to 9. Only it is greater than f of 9. So this is psychological that plays the huge role to get confused to solve such type of questions. Only here we have to use, because it is a bijective function, therefore it is 1 1. 1 1 means strictly increasing. Strictly increasing means f of 3 is greater than f of 9. It cannot be equal to f of 9. Correct? So finally we are having here like that f of 15 and like that. And if it is the thing, then it is a strictly decreasing function. If it is a strictly decreasing function, that means we have to search for total number of 1 1 function. But it is bijective as well. So what about the onto functions? Should we calculate the onto functions separately and 1 1 function separately? That is the question comes in the mind of students. That means lots of confusion over here. See, if you find out the 1 1 function, okay, strictly increasing function, then automatically it becomes onto function because of this strictly decreasing condition. And also there should be the equal number of elements in the domain as well as in the codomain. Let's see here 1 3 5 7 up to the 99 means domains contains 50 elements, and codomain contains 2 4 6 8 100. That means codomain also contains 50 elements. So the number of elements in the domain set and the number of elements in the codomain set both are same. Therefore, to find the number of bijective functions, we need to just find out the total number of 1 1 function. And 1 1 function we can find out because it is a bijective function. Therefore, this is f of 3 is only greater than f of 9. Not it is equal to. Correct? And 1 1 function. So, therefore, it is a strictly decreasing function. Got it? Okay. Now, coming to the third one, let R is A, B, C, D. R contains this element, S contains 1, 2, 3, 4. R contains 5 elements, S contains 4 elements. Okay, fine. Then we have to find out the total number of onto function. Now, how to find out the total number of onto function? First, I am telling you that the total number of onto functions can be found out by the concept of dividend distribution of distinct objects. Okay, see here there are 5 elements and here there are 4 elements. It means that to find out the number of onto functions without any restriction, I am saying, because I am not reading about this FA is not equal to 1. Without any restriction, the number of onto functions can be found out by using the concept of dividend distribution. That means we are having these 5 distinct books and we have to distribute these 5 distinct books to these 4 children with the condition that each children should get at least one book. At least one book. Then only you can find out the number of onto functions. So, the finding number of onto function is equivalent to the dividend distribution, that these 5 distinct books we have to distribute among these 4 children so that each children get at least one book. Correct? Definitely. So, but there is also a restriction. Without restriction, I have explained to find out the total number of onto function, but they are not asking simply the total number of onto function. They are giving some other restriction. What is that restriction over here? That FA is not equal to 1. So this restriction here, and this restriction here plays the important role. Such type of question they are asking. So we have to give the importance to these restrictions. Okay, you cannot find out the number of function by using some kind of formulas directly, because restrictions are different in every questions. So keeping in mind those restrictions, we have to solve such type of questions, and therefore these questions become difficult, but you have to understand them. So let us solve one by one. We understand these 3 varieties of questions. One is there for strictly increasing, one is there for strictly decreasing, another one is number of onto functions. So strictly increasing and strictly decreasing means one function we have to find out, but with certain restriction. And onto functions means we have to find out the use the concept of divide and distribution, but with certain restriction as well. Okay, fine. So let's do the first problem. See, A contains 1, 2, 3, 1, 2, 3, 4, 5 and 6. This is A. And B contains 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is the set B. We are finding the number of functions which are strictly increasing, that is we have to find out the number of one function. Number of one function. But hold on. There is a restriction also that fi should not be equal to I. So fi should not be equal to I. Here is the trick to solve this question. Say f1 is not going to 1. f1 is not equal to 1. That is f1 is not equal to 1. Correct. f1 is not equal to 1. Then we have to find out the number of one function. Correct. If 1 is not there, then we are remaining with 8 elements, where this 1, 2, 3, 4, 5 and 6 should associated with these 8 elements, with the condition that the function should be strictly increasing. So therefore 1 should go to 2 only. It cannot go to 3, because if it is going to 3, 1 is going to 3 or 4 or 5 and 6, then this 2, 3, 4, 5, 6 has to go. Any one of them has to go to 2. So in that situation the functions cannot be strictly increasing. Correct. So therefore 1 has to go to 2. So automatically this 2 will go to 3 or 3 will go to 4, and like that we can find out the number of R 2 will go to not 80, 1 is going to 2, 1 can go also to 3, 1 can go also to 4 and like that. But the 6 element we have to select from these remaining 8 elements. These are the 8 elements. 1 is okay, 1 deleted. So out of these 8 elements we have to select 6 elements, and definitely those 6 elements are distinct. Correct? Those 6 elements are distinct, and we have to associate these 1, 2, 3, 4, 5, 6 in such a way that the function becomes strictly increasing. So simple answer is select 6 out of these 8 elements. If we select these 6 elements, now we can associate these 1, 2, 3, 4, 5, 6 element with these 6 element in such a way that that function becomes strictly increasing. That is, this is only one way we can arrange them. So this is into 1. Correct. So finally 8c6, that is 8c2, that is 8 into 7 divided by 2, that is 28 is your answer. 28 is your answer. So the calculation is very small, but understanding the question is difficult. If you understand the questions properly, it will take the time. It will take time to understand the questions. Calculation is not at all horrible over here. So first question is over. Now coming to the second question. First question is over. Okay. Coming to the second question. Now second question is again interesting. There are 50 elements. 1, 3, 5 up to the 99 in the domain set, and also there are 50 elements in the codomain set. Okay, and we have to find out the number of bijective function, but with the restriction. The restriction is this: f of 3 is greater than or equal to f of 9. If it is bijective, then I have already explained about that. It should be 1, 1. If it is 1, 1, then f of 3 cannot be equal to f of 9. Only f of 3 can be greater than f of 9. So therefore, it is 1, 1 function. And as the number of elements n of A equal to n of B, therefore 1 function will give onto function. Correct? The function is 1 means automatically it is onto as well. Got it? And therefore it is bijective. That is important. So now with these first element we have to arrange. So how many elements are there? See, there is 3, then 9, then 15 up to the 99. So 99 equal to A plus n minus 1 into D ka formula. A is 3, n I don't know, that we have to find out. D is 6, okay. So this is 99 minus 3 means 96 divided by 6. Okay, 6 1 ja 16 equal to n minus 1. So n equal to 17. You can easily calculate it that these 17 elements, that is what, 3, 9, 15, 21 and 99. These 17 element has to be arranged in such a way that this condition satisfied. That is only greater than. Correct? This condition is, and that can be done by in only one way. That can be done in only one way. So therefore we have to select 17 elements out of these 50 elements first. So I am selecting here, this is 50, I am selecting 17 and then arranging them, and the arrangement, number of ways of arrangement which follow this rule is only one. But as the function is 1, so what about the remaining elements? So remaining elements we are having 17 we have arranged. Now we are remaining with 33 here, 33 here. Correct? So 33 elements can be arranged in 33 factorial ways. So this is your answer. You can also write down this is the 50C 33 into 33 ka factorial, that is 50P 33. 50P 33 or this is 50C 17 into 33 ka factorial is your answer. Understood? Okay, fine. Now coming to the very important question, that is the third one. Third question is again a very important, and here we all can commit the mistake if we do not understand the concept of onto function. And in the examination, definitely such type of mistakes everybody, most of us can commit. Here the question is, let R is A, B, C, D, E. Okay. R is A, B, C, D, E. Only 5 elements. And S is containing 1, 2, 3 and 4. Okay. R2S. And we have to find out the total number of onto functions. Only if it is total number of onto functions, then it is the question of divide and distribution. That is 5 books, 5 distinct books. 5 distinct books we have to distribute among 4 children with the condition that each boy get at least one book. At least one book. So how we will do? We can do like that. This is 5. Okay. We can give 1, 1, 1, 1 to each boy. But still we are having one more book. That one more book has to give to any one of them. Same I am giving to 2. So divide and distribution says that this is the 5 factorial, 1 factorial, 1 factorial, 1 factorial and 2 factorial, as 1 coming 3 times. So 1 upon 3 factorial. This is division and we have to distribute among these 4. So therefore this is 4 ka factorial. Correct? So what is the answer? Answer is 5 into 4 into 3. 5 4 factorial means I think that 120. 2 factorial means 2. 3 factorial means 6. And 4 factorial means 24. 12 2 ja. That is what? 240. So without any restriction you can find out the total number of onto functions, that is 240. You understand the total number of onto function, how I can find out? By using the concept of divide and distribution. Fine. Now, but we have to solve this question with this restriction, that fa should not be equal to 1. This is important. fa should not be equal to 1. So how we can do that? fa should not be equal to 1. So this is without restriction. So let us find out the number of onto function when fa equal to 1. This is important, because this is the total number of onto functions. This contains when fa equal to 1 or fa not equal to 1. All these cases are already included over here. But we don't want those cases where fa is not equal to 1. I don't want those. So therefore I will calculate when fa equal to 1 first. So fa is going to 1. A is going to 1. Correct. So we have to now, here comes the important concept. Here comes the important concept. What is that? How to distribute this ABCD, okay, ABCD, how to distribute among these 1, 2, 3, 4 or ABCD 2, 2, 3 and 4, correct? Because we want onto functions. So BCDE, this is BCDE, okay, BCDE, okay. BCDE can be distributed to 2, 3, 4, or BCDE can be distributed to 1, 2, 3, 4, because we have already assigned A to 1, correct? So if BCDE all goes to, means they are associated with 1, 2, 3 and 4, the still functions remains onto. So therefore I can find out 4 factorial by, okay, 1 factorial, okay, I can have 4, this is 1, 1, 1, 1, correct, 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 upon how much? 4 factorial into 4 factorial, up to this division, and this is for distribution. So this gets cancelled out, that is only simply 4 factorial. 4 factorial means 24. But I can also distribute this BCDE only with 2, 3, 4, because A is already assigned to the 1. Still function will remain onto. That is important point. Correct? If I distribute this BCDE, so this is what? 4 factorial, 1 factorial, 1 factorial, and 1 will get 2 amount. Why? Because 4 can be distributed into 3 in 1, 1, 1 for one onto function. So I can give one more to any one of them. So therefore 1 factorial, 1 factorial, 2 factorial, 1 upon 2 factorial, because 1, 1 is same, and distribute among 3, that is 3 factorial. So this is coming to be what? 24 by 4 into 6, that is 6 into 6, that is 36. So either this or this. So total base 24 plus 36. 24 plus 36 is 60. So we have to subtract 60 from here. Correct? 60 why? Because we have considered that A is going to 1. But I don't want A going for 1. That number of onto functions I want. So therefore the final answer is coming from 240 minus this 36 minus 24, that is minus 60. And therefore the final answer is 180. 180 is your final answer. So in these questions, what generally students commit the mistake, either they can consider this only or this only, not both of them. That is the common error. Okay.